morning everybody. This is Divyavani working as Assistant Professor in CSE Department in Institute of Aeronautical and Engineering College. And today's topic is Fundamentals of Finite Automata. These fundamentals of finite automata, basically we call them as also as a building blocks of the finite automata. So first, before that, what is a finite automata? This finite automata is used to recognize the pattern. So whatever the input that we are going to give a system or a machine, that has to give some output. So in order to execute this finite automata, in this finite automata we are going to give some inputs as some patterns or a strings we call. This finite automata, we also call them as a finite state machines. Finite state machines. So now coming to the finite state machines or in the finite automata, in order to learn that, we are to learn the fundamentals or the building blocks of that finite automata. Right? Next, coming to the what are the building blocks of the finite automata or fundamentals of finite automata. So first one, we call it as a symbol. Symbol is nothing but it is the smallest building block which can be any alphabet, letter or any pictures. So how can we represent that alphabets, letters or a pictures? Like we can write alphabets are like as A, B, C and so on. Any alphabet either in a small letter or a smaller key, small letters or in a capital letters. And coming to the letters, 1, 2, 3 and so on till 9. We can also take 0 as a letter. And the pictures either we can take this type of pictures or else any type of pictures, or also we can consider them as a symbols. The next building block is an alphabet. So this is a continuous process how this symbol, alphabet, string can be used. It will be a step-by-step process. The first we will learn about the symbol. Then next coming to the alphabet. Here alphabet is nothing but it is a finite and non-empty set of input symbols. Right, non-empty set of input symbols. That means if I combine 2 or more input symbols, then we call them as a alphabet. So here how this alphabet is represented means we represent this alphabet by using a symbol called sigma. Right, this is called as a sigma. We call them as a sigma. The example for this alphabet is nothing but if I consider a 2 input symbols or a symbols, we call it as a 0, 1, right? It is a set of input symbols. Or else I can take an input symbols like A, B or a C. I can also take input symbols like as 1, 2, 3 and so on. So I can take any of these symbols as a non-empty set of input symbols, then we call it as an alphabet. Then next coming to a string. A string can be defined as a finite sequence of symbols. Finite sequence of symbols. So that are chosen from an alphabet sigma. So where these strings are coming, we are taken from the alphabet. Right? Alphabets are taken from the string symbols and the strings are taken from the alphabet. So these strings we represent it by using a symbol called W. We represent the strings by using the W. So here I have given some examples. A sigma equals to A, B and a sigma is 0, 1. Right? These two we call them as an alphabets. Right? So on these 2 alphabets, how can we form the strings? The strings can be either the W can be a sequence of symbols. Sequence of symbols, that is 0, 0, 0, 1, 1, 0. These all the strings. 0, 0 is one string, 0, 1 is one string, 1, 1 is one string and so on of any length of string 0, 0, 0. This is a 3 length string and so on. So these all comes under the strings. So these we represent the W as a string we represent W as a string. And we have one more thing, the length of the string. The length of the string is denoted by the mod W. The mod W is called as length of the string. And in these, we are having a strings called 0, 1, 0, 0 and everything. But here we are also having a string called epsilon. We call it as a epsilon. So this epsilon we call it as empty string or null string. So the length of this particular empty string is equals to 0. For example, if I want to tell something like if the string length is equals to 0, what is the string that we derived from this is we call it as a epsilon. If the string length is equals to 1, we on the input symbols 0, 1, we get the output like as 0 and 1. Right? Or else if I contains a string length is equals to 2, on the same input symbols 0 and 1, I will get the outputs as 0, 0, 0, 1, 1, 0 and 1, 1. So this is how the string length will be derived and the strings will be defined by using an alphabets or by using an input, by taking the input symbols. Okay, the next string that we are going to learn is the operations on the string. So we have learned how the strings is derived and what are the operations that we are going to perform on these particular strings. So here we are having a length of a string, prefix of a string, suffix of a string, proper prefix or proper suffix of a string, substring of a string, reverse of a string, palindrome of a string, union of two strings and concatenation of two strings. So these are the operations of the strings. So now we are going to learn them one by one. So first one is called length of a string. The length of string is nothing but it is defined as number of symbols in the given string. The number of symbols in the given string. Already I have told you that the length of the string is defined by using the mod W. So right, if the string is AB, what is the length of the string here? The length of the string is 2 because it contains two input symbols A and B. The length of the string is AB here. So in the same way, if the string is ABCD, and what is the length of the string here? ABCD. We have 4 input symbols, right? 4 symbols, alphabets that we are having. So the length of the string is 4. So if I have a string W is equals to AABC and the length of the string is equals to 4 here. Even though the A is repeated twice, we count them 2 times. So A and BC, the length of the string is 4. Right? As I have told you that the string is epsilon. When the string is epsilon, what is the length of the string? When the string is epsilon, the length of the string will be 0. The length of the string will be 0. That is nothing but the epsilon is represented as a empty string or a null string. The next one is prefix of a string. The next one is prefix of a string. So this prefix string is nothing but it is called as a leading symbols in the given strings. So what is called leading symbols? That from the starting symbols to the ending. So if I take a string called ABCD here, so what are the prefix that I can take it from that particular string called ABCD? So what are the prefix that I can able to take? I can take epsilon, right? Starts with the null string, empty string, and I can take A and next AB, next ABC and next ABCD. So these are the prefixes or we call them as a leading symbols in the given string. So any of the string that I take. So if I take a string called AAB as a string, so then I get the prefixes as epsilon, A, AA and AAB are my prefixes. right? Then next, coming to the next operations on the string is suffix of a string. Suffix of a string. It is nothing but, in the previous prefix we call it as a leading symbol, right? In this suffix of a string we call it as a trailing symbol in the given string. That means from back to front. That here I have taken an example called ABCD. That's the same example that I have taken, ABCD. So what are the suffix of that particular ABCD? So from this particular string, I take suffixes are starts again with the epsilon, right? Empty or a null string. So starting from the backward, trailing, right? D, CD, BCD and ABCD. Right? If I take a string called ABC or else AABC. So my suffixes are epsilon, C, BC, ABC and AABC are my suffixes. Okay. Next one is a proper prefix or a proper suffix of a string. Already we have learned what is a prefix or a suffix of a string. Now we are learning about the proper prefix or proper suffix of a string. So what is the difference between the proper prefix and a proper prefix? So that is a proper prefix or a proper suffix, right? That is nothing but it contains strings other than the given strings. In the proper prefix or a proper suffix, it contains strings other than the given strings. For example, in the suffix, if I take this example here, it contains ABCD as a given string. So in the suffix itself, we are also having the ABCD as a string. But where coming to the proper suffix, it doesn't contains the given string in that particular proper prefix or a proper suffix. So here if I take a string called ABCD example, so in the proper prefixes, it starts from the leading symbols that like as epsilon, A, AB and ABC. It ends with the ABC itself. It is not going to take another string called ABCD. That means it contains strings other than the given string. The given string is called what? ABCD. It doesn't contain the ABCD string. So that is a difference between a prefix and a proper prefix. In the same as the suffix and the proper suffix, it also doesn't contain the given string. See here. It starts from the trailing. It starts with the epsilon, D, CD and BCD. It doesn't contain a string called ABCD in the suffix. That means that is a given string that we have taken. So this is a difference between a proper prefix or proper suffix and prefix and the suffixes. Okay. Next one is, so here I am going to give a small note for this. In order to find the prefixes or a suffixes, if it is a finite length of the string, we can find we can count how many number of prefixes or how many number of suffixes can be derived from that particular string. But if the given string length is infinite, how can we find that how many number of prefixes or suffixes or proper prefixes or proper suffixes will be derived from that particular string? So here I have given an example like if the string length is n, it can be any length of the string, right? It can be any length of the string. If the string length is n, the number of prefixes derived from the n length string is n plus 1. And the number of suffixes derived from the string length n is n plus 1 again. And the number of proper prefixes derived from the string length n is n. And the number of proper suffixes derived from the string length n is again n. Right? Okay. So this is a small. By using this formula, we can derive any length string. We can find what is the string length of number of prefixes or a number of suffixes. The next operations on the string is a substring. This substring is nothing but every prefix and suffix of a string is a substring of the string. So whatever the prefixes and suffixes that derived from a particular strings, all those strings we call it as a substrings. So here I have taken a string called AB. AB string I have taken. Right? From this AB string, I have a substrings called epsilon, A, B and AB. Right? Every prefix and suffix of a string is a substring of a string. Okay? Then if I take an example called ABCD for the substring, so what are the possibilities that I have derived substrings from that particular string? Those are epsilon, A, B, C, D, AB, BC, CD, ABC, BCD and ABCD. So here, even though in this substring also, if it is a finite length string, we can count the number of substrings derived from the given string. But if this given string is infinite string, how can we count those number of strings? So here we have a formula called n into n plus 1 by 2 plus 1. So this is a equation. By using this, we can count any length of the string, how many substrings are derived from the length of any length strings. Okay, so this is a substring. The next one is called reverse of a string. The reverse of a string is nothing but the particular string, whatever the string that we have taken, that will be the reverse of the particular string. So we represent the particular reverse of a string by using the W power of R. We represent the reverse of a string by using the W power of R. So here I have taken an example called, I have taken a string called ABC. And what will be the reverse of that particular string? The reverse of the particular string is C, B and A. C, B, A. So in the same way, if I take a string called 1, 2, 3, and what will be the reverse of the string? The reverse of the string is 3, 2, 1. Right? Okay. The next one is a palindrome of a string. What is called palindrome of a string? When the string is equals to the reverse of a string, then we call it as a palindrome of a string. When the string is equals to the reverse of a string, then we call it as a palindrome of a string. So here I have taken example called ABA. So whenever if I do the reverse of that particular string, W power of R, the string what I have taken should be same as the reverse of the string. That is, the reverse of the string also I have turned is ABA. Right? If the string is called 1, 2, 1, what is the reverse of that particular string? 1, 2, 1 again. So here whenever the W or a string is equals to reverse of the string, then in this case we call it as a palindrome of a string. Right? Clear? The next one is union of two strings. Union of two strings. Here union is nothing but we combining the two strings. So here union is represented by using this union symbol, or else we represent it with the plus symbol or with the vertical line. We can either represent it with the union symbol, plus or with the vertical line. So how this union will be performed by in between the two strings. So if I take a string called W1 as AB and W2 as a CD, if I perform the union between those two strings, W1 union W2, I get the resultant as AB comma CD. AB comma CD. I get the set of strings called AB, CD. So this is called the union of the strings. The next one is called concatenation of the two strings. This concatenation is nothing but it is combining the two strings into a single strings. So if I take a string called right before that, this concatenation of the two strings is represented by using a dot symbol in between the two strings. So here I have taken a string one called W1 as AB and W2 as a CD. So when I perform the concatenation between these two strings, what is the resultant I will be getting is, I get this resultant string as ABCD. Okay, so these are the operations on a particular strings. The next building blocks of the finite automata that we are going to learn is called as a language, right? So language. What is called a language? Language is nothing but whenever if we collect a string of when we collect a collection of strings, then it called as a language, or we call it as a collection of strings. A language is a set of all strings that are chosen from the alphabet again. Where these language strings are coming, these are set of all strings that are chosen from the alphabet. It is denoted by using the L is a subset of epsilon star. Language is the subset of epsilon star. So here what is this epsilon star? Epsilon star is nothing but it contains the set of strings of any lengths from the 0th length to the infinity of the length. So every language will become as a subset of this particular epsilon star. This epsilon star we call it as a clean closure. We call it as a clean closure. So where here this language we represent it by using the capital L. We represent the language by using a capital L. And a language is classified into two types. One is a finite language and a infinite language. The language is divided into two types. One is finite language and infinite language. Finite language. What is a finite language? When a language is said to be finite if it contains a finite number of strings. If it contains finite number of strings. If the string length is equals to 2 over an input symbols 0, 1. Over an input symbols 0, 1. Over an input symbol 0, 1. So by using this, what is a finite language that I can derive? Language equals to 0, 0, 0, 1. Possible outcomes of a strings are 0, 0, 0, 1, 1, 0 and 1, 1. So these are all the possible outcomes derived from the string length is equals to 2 over an input symbol 0 and 1. So this sort of length of a strings we call it as a finite languages. So that means finite number of strings I have derived, only 4 strings in my language. So this sort of languages we call it as a finite languages. And a language is said to be infinite language if it contains infinite number of strings. If it contains infinite number of strings. So if I take an example, if a string length is greater than or equals to 2 over an input symbol 0, 1. So what are the possible outcomes that I can be derived if the string length is greater than or equals to 2? So the languages is, what are the possible outcomes? Equals to 2 means it starts from the 2 and 2 and above. That is 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0 and so on till the infinity. Greater than or equals to. So these sort of languages we call them as the infinite languages. Okay, the next we also contains operations on the languages, and those we call as concatenation of languages, union of the languages, intersection of two languages, difference of two languages, power set of two languages, clean closure of two languages, and positive closure of the two languages. And positive closure of the two languages. The first one that we are going to learn about the concatenation of the languages. So here the concatenation of the languages we represent. If I take a in strings as a perform two languages, the language A is equals to 1 comma 2 and the language B equals to 2 comma 3. If I take an example and perform this example between all these perform this example on the all the operations that I am taking. Okay, first one is concatenation of the two language. So here concatenation of two language we represent it with the A cross B. We represent it with the A cross B. So let me solve here A cross B. So what is A here? 1 comma 2 and B is 2 comma 3. 2 comma 3. So if I perform the concatenation operation between these, what are the resultant that I will get? 1 comma 2, 1 comma 3, 2 comma 2 and 2 comma 3. So these are the resultant that I will be getting. So the next one is union of the two languages. The next one is union of the two languages. So how the union of the two languages will be represented? I already told you in the strings union will be represented by using the union symbol. By using this union symbol. So how to perform the operations on this particular two input languages? So A union B. So what are the common the elements which are present in those two languages that we will be taking? 1 comma 2 union 2 comma 3. From these I get the input symbols as resultant as 1 comma 2 comma 3. All the possible outcomes or input symbols present in between these two languages. The next one we are learning about the intersection of the two languages. Intersection is represented by using the intersection symbols. This intersection is represented by A and B. And symbol. This we call it as and symbol. A and B. So 1 comma 2 and 2 comma 3. 1 comma 2 and 2 comma 3. So how to represent this? Intersection means in these two languages what is a common thing that we are, common element or input symbol that we are having. From these two we are having a common element as a 2. So this is the A intersection B. Right? The next one is called a difference of the two languages. The difference of the two languages. Here we are having a two languages of A and B. So I can find A minus B. Difference means minus, right? Minus B and B minus A. Right? Right. First A minus B. Right? From A, what is A here? 1 comma 2 and minus 2 comma 3. So what is a possible A minus B? The possible resultant, if I minus this from this, I will get the 1 as a resultant. Right? In the same way, if I do B minus A, right? 2 comma 3 minus 1 comma 2. Here if I do the B minus A, I will get the resultant as a 3. I will get the resultant as a 3. Right? The next one is a power set of two languages. Here we represent the power set by using the 2 power of A. We represent the power set by using the 2 power of A and 2 power of B. The power set, how to find this power set? Right? The power set, if here A is a power set, what is the elements of the here 1, 2? What is the power set? The possible power sets that will be derived from this particular language 1, 2 is, first we start with the 1, 2, 1, 2 and null. Right? The power sets which are derived from the 1, 2 are 1, 2, 1, 2 and the null. And next one is 2 power of B. Right? We have to find the power sets of B, that is 2, 3. What will be the resultant? We get the outputs as 2, 3, 2, 3 and null. So this power set includes the elements which are present in that as well as with the power sets. Okay. The next one is clean closure of the two languages. Right? Clean closure. We represent this clean closure or of the languages by using the L star. Basically, if it is a clean closure, we represent it by using the sigma star. If it is a clean closure of languages, we represent it with the L star. So, what is this clean closure of two languages? It contains a set of all strings of length 0 or more number of occurrences. That means it contains all the string lengths 0 and above. 0 and above. That means how much above? Infinity. Which accepts a set of all strings of length 0 and above. We call it as a epsilon star. So clean closure. And it is represented by using the L star. The next one is called a positive closure of two languages. Here the positive closures always represent with the epsilon plus. But here the positive closures of two languages, we represent it by using the L power plus. Right? And in these, if I take what is this positive closure of two languages? So in this clean closure, we starts with 0 length string and ends at the infinity length string. Right? Then what is positive closure means? It doesn't contains a empty string. It doesn't contains an empty string. What is empty string? Here I have told you that it accepts the string length called 0. That means what is a 0 length string? Epsilon. Here it doesn't contain the empty string. That means a positive closure always starts from the length 1 to the infinity. It always starts with the length 1 to the infinity. It doesn't contains a empty string or a string length of 0. So that is a difference between the clean closure as well as the positive closure. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.